Hi, and welcome to the video, blurring and sharpening of images. So let's take a look at how we actually do this. So firstly, what is a convolution and how does it relate to blurring? Well, firstly, a convolution is a mathematical operation performed in two functions producing a third function, okay? Which typically is a modified version of one of the original functions. So now that probably still doesn't help you understand what's going on. And neither does this formula here, which is just a mathematical illustration, a very simplified one of what's happening there. And in computer vision, we use these kernels to specify the size of which we are manipulating a function over our image, okay? And this is what a 5x5 kernel looks like. And I'm pretty sure this doesn't help you understand what is happening. However, what you need to keep in mind is that a convolution is an operation whereby we run a matrix over our images here. So it's like a square matrix of a specified size, and this one is a 5x5 here. And it's performing some operation on these pixels here using the inputs of this region here on the image, okay? So imagine this is the image here. This 5x5 region is the image we're considering. This function here is some function that's a 5x5 matrix here. We're multiplying it here, and we're getting an output of it. So now this probably should help you a little bit more. This is our kernel here in our elephant image here. And this is what a kernel looks like here. It's just imagine it's a simple one. It's just all ones here, and it's multiplied by 1/25 here, which is because it's a 5x5 matrix here. And we're multiplying it here so that we normalize, keep it summing to 1. Otherwise, we don't want to increase the intensity of this operation because this operation is a blurring operation here. So by doing this, running this convolution over all the pixels of the image, like imagine we're sliding this across the image, we're effectively blurring the image here. And that's how we end up with this blurred image. Now, why do we blur images? Now, blurring images is something a lot of people seem to be confused. Why does this operation even exist sometimes? Well, I can tell you, blurring actually helps a lot of computer vision algorithms work a lot better because it actually smoothens the image, so it reduces the noise or the detail or the sharp edges, which can be interpreted as noise in some algorithms like canny edge. Canny edges work a lot better sometimes when slight blur to the image as opposed to a detailed sharp image like this, because what happens is that when canny edges does this, it's going to identify sometimes way too much edges in the image. And even though you can adjust parameters of the canny edge algorithm to reduce the sensitivity, you may sometimes just want to blur the image slightly, maybe not so much like in this output here, but just to a small degree so that it actually helps a lot with the canny edge algorithm. So there are other types of blurring. That was a very simple blurring here that averaged values over a specified window. However, there's Gaussian blur, which is similar but uses a Gaussian window, so there's more emphasis on weighting the points around the center. Remember, we have 5x5. Let's take a look. 5x5 kernel here. With a Gaussian one, the points that are close to here are more emphasized, so okay, or more important as opposed to the points here. Remember, normal or Gaussian distribution is a bell curve, so the points at the lower or the extremities are less weighted or less important in the blurring. Okay, so there's ultra-median blur, okay, and there's bilateral blur. I'm not going to read all these here, but we're going to actually use them in OpenCV in our practical chapter, so you can take a look at how they work there. So now let's take a look at sharpening. Now, sharpening is the opposite of blurring. It strengthens or emphasizes the edges in an image, and this is an example of a sharpening kernel right here. So our matrix still sums to 1. You can add it, check it here. So there's no need to normalize. That is multiplied by a factor to retain the brightness, like what we did right here. Okay, by the way, this was a blurring kernel right here. So this multiplying by 1s is sort of like an averaging across of all the pixels here. So that's how we actually blur it. So now let's move on back to this. So this is what regular image looks like, and this is what a sharpened images looks like. And you can see it's basically when people say an image is over sharpened, it looks a bit artificial, like all of these points a little too emphasized, a little too, I can say jagged sometimes if you want to describe it like that, just a little harsh and a little bit hard. So that's what a sharpened image looks like. So sometimes it does add the deal. So what have we learned in this video? Well, we've learned how images are blurred using convolutions, some other types of blurring algorithms, and how sharpening or what sharpening is and how it's done. So now let's actually move on to practical aspect of blurring and sharpening images in OpenCV.